Okay, so part 3 of this lesson builds on what we just talked about with respect to what the interface does, and we're going to take a quick look at how the ThreadPool Executor, which is a Java class that's part of the Java util concurrent package, implements the ExecutorService interface. So now we're kind of shifting from the API into the what's actually going on behind the scenes. So ThreadPool Executor is a class. As you can see, it indirectly implements ExecutorService. It does that indirectly because it actually extends abstract ExecutorService, which is this superclass. It's a reusable superclass that implements the ExecutorService interface. And it has a boatload of methods. You can actually use ThreadPool Executor directly if you want to. We're going to use it almost exclusively in the context of the, at least for now, we're going to use it exclusively in the context of the ExecutorService interface. You'll see later why you might want to implement this yourself. And what this does is it takes each submitted task and it runs each task in a worker thread provided by a pool of threads. So here's kind of what it looks like. You have a runnable or a callable, and you submit this to the ThreadPool Executor, and that queues things up here in the list, in this queue, which is a unbounded blocking queue. And then one of the threads, whenever it's available, will pull the next available runnable or callable out of the queue and then run it to completion. And then when it's done, it'll go back and find the next one to execute. And since you have a pool of threads, conceivably you can chunk away through this queue of pending tasks faster than would be the case if you had a single thread. The queue itself can be strategized. So when you make a ThreadPool Executor object, you or the factory method in the executors class can just make some certain decisions about how things are going to be created for that executor, ThreadPool Executor. So one thing you can use is what's called direct handoff, and that's used by a cached thread pool. And what this does, it's a really funky mechanism. It's implemented by a class called a synchronous queue. It's really funky. And what it does is when you submit a task for execution with the synchronous queue, it actually will create a new thread to handle that request if there is not already a thread available to run it in the pool. If there's a thread available in the pool to run it, it'll give the work to that thread. But if there's no thread in the pool, rather than queuing things up, it'll actually create a new thread on demand. So it's kind of an on-demand creation approach. That's what's called direct handoff. The good news is it'll keep spawning these threads, which helps to avoid some problems with deadlock. The downside is you can make a lot of threads. You can have a lot of threads created very quickly if there are none sitting around idle waiting to be used. So for heavily bursty traffic where lots of requests come in at the same time, this approach can end up sort of drowning itself with too many threads being created. The approach that you get for fixed size thread pools is to use what's called an unbounded queue. And as the name suggests, it's an unbounded blocking queue. As the name suggests, as new work comes along, it just gets stuck at the end of a queue, and that queue can grow indefinitely. Now, obviously, there's a limit. Like when you run out of memory on the machine, it's done. But up to that point, the queue can continue to grow. The good news is that it smooths bursty requests. Much like the reason why I have a picture of Santa Claus with dollars in his hand is because a lot of stores do seasonal hiring during the holidays to handle bursts of traffic, people showing up at their store, right? So if you're Walmart or you're a mall or whatever, you'll hire people there. And at that point, you sort of hire as many people as you need to keep the queues from overflowing. The downside is you can consume a lot of resources, namely memory resources. So the problem with the direct handoff approach is you can create an unlimited number of threads. In this case, you're consuming an unlimited number of basically messages to be put onto queues, which probably are not as big, by the way, as threads, but it could still eventually eat all the memory. And then the third and final approach that you can use here are called bounded queues, which you can also use if you so choose. And as the name suggests, you limit the amount of things that are in that queue. The good thing is you can limit the utilization of resources, so you can keep yourself on a a memory diet, if you so desire. The downside is trying to figure out the number of items to put in that queue is tricky. Like, how big should it be? So it's hard to tune, like a 24-string guitar or whatever. It's like, how do I tune this thing? And secondly, if you're not careful, you can end up with deadlock. And you can read more about why thread pools can lead to deadlock at this particular link. OK, so that was just a quick summary of the ThreadPool Executor class, which we will visit later in the course, and you'll get a chance to actually use it in its full-blown glory. Most commonly, however, you access this class through the new cached thread pool and new fixed-size thread pool factory methods on the executors class or utility class.